that when you take in any, remember we're talking only about right triangles. It only works with right triangles. You can't do this with any other triangle than right. If you take A and square it, which is like this one, this side right here is 3 units. If you take 3 times 3, you get 9. That's the area of this little square right here. Add to it B squared, which is the area of this side here, which happens to be 4 times 4, which is 16. You are always going to get the hypotenuse, that long side, the area of the long side. If I take C times C is 5 times 5, and you get 25. Works for any right triangle. And the beauty of that is, if you use that formula, you can always, 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 I told you construction people use this all the time. You know, if you're building a ginormous building and you want to make sure that the walls are square, you know, how do these guys know when they're building a house if their walls are square? There's a couple different ways you can do it if you've done it before. One of them is to use this Pythagorean theorem. Okay? Now the unfortunate thing about this is there are only certain ones that work out nicely. Okay? There are only certain ones that work out really nicely. They are called the Pythagorean triples, and I'm going to give them to you. So you have your own very own copy of the Pythagorean triples. These are the ones, and there are other ones that work out, but these are the basics. Garden variety, standard Pythagorean triples. They're on the wall, so if you lose this, you don't have to come get it. It's right there, but it's always good to put them in your notes. Somewhere in the reference section, so when Mrs. Stone says if you use the resources, you will be able to pull that right there and get there. So what this means to you and me in everyday applications here, under the triples, what that means is if you have a triangle here, and the book gives you 2 of the dimensions, let's say it gives you, this is 7 and this is 24, and they say find side C, okay, the first thing you look for is you ask, is it a triple? So you'll look at your little chart and see, make sure you understand this. These, you have to be, we talked about these, the legs have to be the first 2 given. So when you go to your triple, you need a 7 and a 24 in the first 2 columns. Is there a 724? Yes. 724. You automatically know that the hypotenuse is 25. Okay? And you should say, hey, let's try this. Does this actually work? Back if you're building a building and you wanted to make these 2 walls square, I know, here we go, this is the actual demonstration of this in progress here. Some of this is based upon our, you got a measurement, a little measuring tool here. Give me Aubrey. Grab this. Hold this right up against the wall, just like this. Like that. If you would be so kind, I'm going to measure over 7 feet. Here is 7 feet. Make a little mark here. At 7 feet, I make a mark. My other triple was what? 25? 20 what?
24.
Whew. All right, turn around. Hold it right here up against the other side. I'm going this way now. 24 feet. What did I do with that shirt? How far is 24 feet going to get? You're going to make the Einstein? Oh, here it is. Oh, great. It's on my ball. How am I going to do that? Grace, come here. Hold your finger right there. Don't ever, no, in midair. Do not move it. All right, now Aubrey. Take yours and put it right there where I made that mark on the chalkboard. If this is true and Grace Christ has not, right there under the 29, that little big mark right there. If this is true and Grace Christ has not moved, pull that over time. If this is really true and Grace Christ has not moved her finger, I'm going to pull on it kind of tight. This should, where Grace's finger should end up being how far? 25 feet. 25 feet, it works out for me. How about that?
Magic.
And that's how construction guys would do it. They would start with their one wall, they would measure over their 7 feet, and they would make sure that when they measured this wall here, they would find the exact place where it was 24 from that corner and 25 from there. And you know your wall has to be. It has to be. Now, with that being said, children,
Oh,
now, with that being said, here is what else you have to think about. What if it's not a triple? Say that out loud to me. Okay, first thing you look for is it a triple? The second thing you have to look for before you go crazy and mad is it a, what's the word I'm looking for? Is it a is it a factor of the triples? In other words, this. Give me a new sheet of paper here. If I've got, by the way, the most common triangle is the 3, 4, 5 triangle. You hear people say 3, 4, 5 triangle. If they ever say that, they're talking about this. Okay? That means this. If your triangle has one side of 3 and the other side of 4, and it's a right triangle, it definitely will be a 3, 4, 5. It'll be a right triangle. Okay. With this as my base triangle, there are an infinite of other right triangles, Pythagorean triples, that are in proportion to it, that this is their base. In other words, this. If I double all the sides and I make this a double 3, if I make it a 6, 8, 10 triangle, that is also a triple. I don't have it listed. I don't have a 6, 8, 10 listed because it goes on forever. Okay, this new triangle is twice the size of the small base triangle. And you could do that forever. You could do one times 3 bigger. If I take these measurements and multiply them all by 3, I get a 9 by 12. How long would this side be? 3 times 5 is 15. Those are all triples, but they're not listed here because if they did, it would go on forever, and you have to be able to recognize that. So if you're given a triangle, let me give you one not drawn to scale. Let's say it is, this is side 15. Use that fly. And this is 20. How long is this side right here? And again, the first thing you look at, is there a 15, 20 triple here listed with those 2 legs? No. The second thing you have to figure out, is it a factor? Does it have a base triangle that it's, a bigger size of? Now, how would I do that? Well, in order to reduce it down, you need to think of, is there a factor that you can divide both by? In other words, if I look at 20 and 15, can I divide them both by the same number evenly? What number goes into 15 and 20? 5. So if you divide this by 5, 4 divided by 5 is, or 20 divided by 5 is 4. That would make this 4. 15 divided by 5 is 3. And then you look at that. Is there a 3, 4 triple?
Yes.
Absolutely, it's 3, 4, 5. So how big would this size be? Here's where people go wrong. You have to remember, if you divided by 5 to get the small one, to go back to the original, you then have to re-multiply that 5 by 5, and the big one would have to be 25. Okay, because this is the smaller version of it. It gets expanded proportionately. 3 times 5 is 15, 4 times 5 is 20, 5 times 5 would have to be that 25. So you have to look for, any of these cases. Here's another case in point. What about this one? And you know it's going to work out because obviously I'm standing up here looking at it. Let's say my hypotenuse is 34. Do declare. My hypotenuse is 34, and one side here is 30. Can I figure out this side based on a triple? Well, again, remember, this is the hypotenuse, so 34 has to appear in this column. There are no 34s. So my next step is there a common factor of 30 and 34 that I can reduce them by? Yes, they're both even, so I can do what to them? I can cut them both in half. So I cut them both in half. This is 15, this is 17. Is there a 17 answer there and a 15 for one of the legs? Yes, there's 17, there's 15. So the third side has to be, but it's not 8 because that's the smaller version of it. Okay, you have to redouble it to get back to the, the bigger size, so this ends up being 16. So yes, it's 16, 30, 34 triangle is a triple. It gets a little confusing and a little wacky, but that's the way the whole thing works. Okay. So, going back to my original thing. I gotta actually see. Hold on a second. Uno momento, please. Parking in the unloading and loading zones only. I need my ball book. What if they're not triples, ladies and gentlemen? What if? What if they don't work out? Do we punt? We do not punt.
We go for it.
We cry. We should go into the gym and measure a big triangle.
Yeah! And then let's go learning.
Maybe.
1663. Then we can make learning.
We gotta know how big. And then we just learning.
We can ball basketball.
Hold on a second. Yeah, okay, so here, we have to figure out this. So what happens, going back to this number, the first thing you look at, is it a triple? If not, is it a factor of a triple? Number 3, if neither of those happens, step number 3 happens. What if it is a 1-1 triangle? How long is the hypotenuse there? There is no 1-1. And that's obviously not a factor / bigger, smaller of that. Then you have to, boys and girls, and this is where you cringe just a little bit, you have to actually use the Pythagorean theorem. Which means in this case, you've got to write out the formula first of all. It has to be a squared plus b squared equals c squared. Sorry. You have to plug in the numbers, and I always use parentheses for letters there. What are my two legs? 1 and 1, so these are both 1s. What is 1 squared? 1 times 1 is?
1.
What is 1 squared? 1 equals c squared. What's 1 plus 1? And here's the problem we have. I now have this. 2 equals c squared. 2 equals c squared, or c squared equals 2. C is what? What is the letter C? How big? What same number times itself gives you 2? That's what c squared means. Ooh la! Is it 1? What's 1 times 1? What's 2 times 2? Okay, so it's gotta be between 1 and 2. Does anybody know what we write down for the answer?
1.5.
No, we don't just guess. Alright, when you have a squared number equal to some number that doesn't have a, if it's not a perfect square, this is what happens. The number C, or the letter C, equals the square root of 2, and that's all you do. You leave it as the square root of 2, because that's what square root asks you. What same number times itself gives you 2? This is what your answer is. C equals the square root of 2. Just like this, let's do another one. What if my triangle was a 1, 2 triangle, and I want to know what my hypotenuse is? Again, you need to write this out. A squared plus B squared equals C squared. A squared plus B squared equals C squared. 1 squared plus 2 squared equals C squared. 1 squared is 1. 2 squared is 4 equals C squared. 5, then, 1 plus 4 equals C squared. C equals the square root of 5. Just know that's what it is. If you have something squared equal a number, that number by itself equals the square root of 5. We'll do this 1,000 times. What if I end up with C squared equals 35? What does C equal? Drew? If C squared equals 35, what does C equal?
Square root of 35.
Square root of 35. What if B squared equals 10? What does B equal? Kate?
5.
Nope,
Or the square root of 10.
the square root of 10. What if A squared equals 25? What does A equal, Grace?
Square root
What do you think about that?
of 5.
A equals, what is the square root of 5? 25?
5.
Yeah, you'd have to put A equals 5. In that case, that's one that works out nicely. Not many do. What if A squared equaled 19? What does A equal? Square root of 19. And you should be able to tell me what the square root of 19 is close to. Ty, what's the square root of 19 close to?
4 and 5.
It's between 4 and 5, because 4 squared is 16 and 5 squared is 25. So 9 squared of 19 has to be between 4 and 5. That's what A is. So here we are, off the real stuff here. I should have put this on my thing here. Let me give you one more to try. So here's my triangle. Let's say I've got a right triangle that is this. Let's say this is 12, and this is 7. I want you right now to tell me what this side will be. See if you can figure that out. Hopefully they give us a problem like this. Maybe they don't. If not, we'll give it a shot anyways. Is it a triple? It is not, I'll tell you that. So you're going to have to do an A squared, B squared, C squared thing. You're going to have to write out the Pythagorean theorem, plug in the numbers, and see if you can't figure out what it is. You get an answer? Anybody going on twice? But again, you don't even try it without writing the formula down. Not even try it without writing the formula down. First thing you should have is this. You should have a squared plus b squared equals c squared. Then you should plug in your numbers. This number is what? A, B, or C? Hypotenuse is long side has to be C, so c squared. Oops, sorry. Doesn't matter. These two are interchangeable. You can put it wherever you want. Let's just put 7 here. It doesn't matter. You could put it for B. Now here's where things run into trouble here. You get 49 plus b squared equals 144. How many people got that far? Where did we not get that far? How did we not get that far? Okay. So I want to know b squared plus what number would b squared have to be to give me 49 plus what is 144? You'd have to subtract this. If you take 49 away from 144, you end up with what? 95? B squared equals 95. If you get that, then B would have to equal Keith.
Square root of 95?
Square root of 95. Which you could tell me the square root of 95 is close to what?
10.
Between 9 and 10. Because 10 times 10 is 109 times 9 is 81. Now, let me give you the sheet here. Believe me, you'll get a lot of practice on this here. A lot of times they'll work out nicely with triples here, and I think they do on this one here. You are going to fill this in. But I need to explain it because you'll look at it at parts and go, I don't get that. And even after I explain it, you'll look at parts and go, I don't get that. So welcome to second grade. Take a look, see at this, will you please? This one, this one. Here's what you're going to do for the first part. You are just filling in the numbers, and these are all triples, so you'll have no trouble with this. In other words, triangle number 1, how long is the short leg? 3. How long is the long leg? 4. You look on the Pythagorean triple thing, how long does the hypotenuse have to be? 5. How hard is that? And you'll do that for those first 6. Then you will come down here. Okay. Problem, it says, using the answers you got in this first table, you're going to plug them into this table here. So problem number 7 goes with problem number 1. The triple you had for this was 3, 4, 5. Right? Is that not number 1? Yes. Then they want you to give 2 more triples that are ratios of those. So if your factor is 2, that means you just multiply everything by 2. So what's your new triple? 6, 8, 10. If your factor is 10, what's your new factor? 30, 40, 50. You multiply everything by 10. And you're just going to do that for all of these here. They do ask you, they give you these here at the bottom. And here's something to think about. What about the last one? Where it's 3 square roots of 7, 4 roots of 7, 5 square roots of 7. Is that a triple? It is, because what base triple triangle is it based off of? The 3, 4, 5. What happens when you double those? What are you going to get? 6 square roots of 7, 8 square roots of 7, 10 square roots of 7, and so on and so on, etc., etc. And then on the back, you are just going to fill in what the question marks are. Let's just look at one. One to get you going here. Problem number 23. I guess we don't have it. What is going to be my third side? Somebody going once, going twice, going 3 times. Is there a 130 leg over here, hypotenuse? No. So obviously you need to check to see if it's a triple. What can you divide both of these by? It'll be easy. Huh? Go high, bigger than 2. 10 because they both end with zeros. So if you divide them both by 10, okay, that makes this a 5, and this 130 divided by 10 is 13. Is there a 13 with a 5? Yes. What's the other one have to be? 12. Now, is that my answer? No, because I divided to get to that. I have to remultiply it by 10 to get my big answer, which is 120. This is something we kind of got to catch on because it comes up